Hello, everybody. It's Mrs. Pound, and we are starting a new chapter, Chapter 3, on measurements in chemistry. We're going to be talking about the measurement system we use, how to take precise measurements, and how to use those measurements in calculations. So, the first thing we're going to talk about in section 3.1a is measurement systems. Now, the videos for this section will be two separate videos. So our objectives for today's video are to explain why we need a measurement system, list the fundamental units of the SI, differentiate between fundamental and derived units in the SI, and explain the benefits of using the SI. So when we talk about a measurement, we're talking about the act of comparing an unknown quantity to a standard unit. And two things we often measure are mass, with using a balance, and lengths, using a meter stick or a tape measure or something like that. Now, we have to make sure when we make measurements that we always record the two essential parts of a measurement. That's the number and the unit of measurement. Um, because a number alone doesn't tell us enough information if we don't know the units. It's like 500 what? So we always have to make sure that we have the units, just like I'm always telling you in calculations, to label your answers. We don't want any, as I call them, naked numbers, okay? So um, right next to this, no naked numbers, okay? With an exclamation point. No naked numbers with an exclamation point. Why we need a measurement system. We need measurement systems because understanding the world around us often requires the use of measurement. We measure all kinds of things to help us understand the world. Measurements are taken to quantify data, signify the need for a standard measurement student system. Um, when we want to compare quantities, we have to have a standard system or it doesn't make any sense. It used to be, you've probably heard of a hand for measuring the height of a horse. Well, my hand is a lot smaller than some of your hands. So if I say that I have a horse that's, say, I don't know, 20 hands tall that I'm going to sell, um, if somebody's looking at their hand and it's bigger, they're going to think I have a bigger horse to sell than I do. And they're going to be disappointed when they see my horse because mine's going to be shorter than they're thinking. So, and that's one reason we need a system of measurement is so that we can be on the same page. Measurement systems also use standardized units to compare objects and convert units of measurement. Like I said, with the horse analogy, you're going to be disappointed if my horse is smaller than you think it's going to be. Also, we like to convert between units a lot of times. We do that, we've done that a lot in science classes previously. So it just helps with that to have standardized units. And this is important for accuracy in recording data and minimizing error in measurement. For instance, if when we're measuring, my centimeter is different than your centimeter, it just does not make for reliable data and comparisons. So we have to all be using the same thing. Now, in science, our standard units that we use are the metric system. This is the widely used method of measurement needed to quantify data in the world around us. Um, the metric system is based on tens, it's base 10, and actually, the whole world uses it except for three countries, just for everything. And one of those countries is the United States that does not use it. So uh, pretty much everybody else in the world uses this system. Now, SI, you might hear, this is the International System of Units. It's another name for the metric system. And it's not IS, it's SI because it gets its abbreviation from the French, which is Système International de Unité. So that's where it gets it from. Now, benefits of the SI system. Only one unit for each measurable dimension. So there are lots of different measurement units out there for length. Um, and just SI standardizes it and said this is the unit for length. There are different units for pressure, all kinds of units. Well, this simplifies it down to one. The units are based on physical constants and can be verified easily. If you want to check out in your book where they get these from, you can. I'm not going to go through each one, but they do use physical constants, things that are easily measured, that are always the same, so that they can verify all of these units. It is a decimal system, so it can be scaled by factors of 10 to measure larger or smaller objects. So we can just push decimals instead of having to use crazy things like, you know, for inches and feet, 12 inches and 1 foot, or 3 feet and 1 yard. We're not having to remember all of these different conversion factors. We know that it's all based on factors of 10, which simplifies it. So the 7 fundamental units are length. And for length in SI, it's the meter, abbreviated with a lowercase m. Mass is actually the kilogram, kg. It's not the gram, so be careful with this one. It's the kilogram. Time is the second. Temperature, Kelvin, not Celsius, okay? It is Kelvin because that's the absolute scale, and that's what we're going to use in our calculations in class. Number of particles, this might be a new one for you, is the mole. This is actually really important for chemistry. We're going to be using this one a lot, the mole. Electrical current is the ampere. And light intensity is the candela, which you can see the word candle there. That one, amperes and candelas, those are more physics. We won't use those so much as we will the others. Now, we also have what are called derived units in SI, and this is a unit of measurement that comes from basic SI units. And an example is the Newton, because the Newton, if we were to write it out, is a kilogram meter per second squared. So that is a derived unit because it's made up of other fundamental SI units. And other examples would be, say, area, which would be a cubic meter, or excuse me, a square meter, or volume, which would be a cubic meter. So volume, like our milliliters and stuff, those are actually derived units. Um, uh, Density would be a derived unit. So we use lots of derived unit, but there are only 7 fundamental units. And then another thing about SI are the prefixes. The prefixes make it easy for us to express much larger or smaller quantities. These are some common ones that you will need to know. Micro, for example, micrometer is, we put in front of the lowercase m for meter, Greek letter mu, lowercase mu. Now, to write a mu, this looks funny. It's basically, it's like a cursive U with a long tail on the front. So that's how you'll write it. You'll make a cursive U with a really long tail on the front. And a micrometer is 1/millionth of a meter, so 10 to the negative 6. And I'll use meter for these examples. So milli, we might have a millimeter, 2 lowercase m's, and that is 1,000th of a meter. So 10 to the negative 3 is the exponential form. And if we look at milli, think millennium. There are 1,000 years in a millennium. Centi, like a century. Cm, 10 to the negative 2, a 100th of a meter. So there are 100 centimeters in a meter, 10 to the negative 2. Deci, like a decade. DM, we don't use this one quite as much. 10 to the negative 1, so a tenth of a meter is a decimeter. Kilo, lowercase k, 1 1,000 meters, so 10 to the 3. And then mega, a capital M, and that is 1,000,000 meters, so 10 to the 6. So mega millions, right? That's why they call it mega millions, um, the lottery that you see sometimes because mega means a million. So our objectives today were to explain why we need a measurement system, list the fundamental units of the SI, differentiate between fundamental and derived unit in the SI, and explain the benefits of using the SI. So don't forget your 5 questions, and I'll be back with another video for this section in your book about measurement.